Today we are starting the very last module in our textbook, that is Module 11, which deals with sampling and statistics. We're looking at Lesson 1. Lesson 1 covers biased and unbiased samples. According to the textbook, we're looking at a 2-day lesson here. We've got 14 resources to get through. Let's get started. In statistics, information is gathered and used to draw conclusions. One way to gather this information is to use sampling. A sample is a portion of a group that is taken for a study. Samples provide a window to the trends within the population as a whole. A good sample is made up of a group that is similar to the whole being studied. A sample about middle school students should represent all the students, not just one age, one gender, or one grade level. You don't just say sample all the football players or all the members on the swim team or all the band students and forget about everybody else, because that would not be a good sample. It would be what we call a biased sample. The U.S. Census Bureau counts a population in a census and uses sampling to collect information about the American Community Surveys, or in the American Community Survey. So here we got on the United States Census. You can see the census is an official record of all the members of the population. The U.S. Constitution requires a census every 10 years, and they have to count every single body. In 2010 census, the population was reported at 308,745,538. By 2050, they expect the population to reach 398 million, and that's quite a bit number of folks there. I'm not sure that that's going to happen, because we have found historically that as things like education levels go up, population levels drop. Interesting, isn't that? I guess the smarter you are, the less kids you want to have. American, or the more educated you are, I should say, not smarter. The American Community Survey says this questionnaire asks a sample about jobs, education, housing, language, and more. And this happens every single year, not just every 10 years like the census. And each year this survey is only sent to 3.5 million household members who are required to complete it. That, in comparison to 308 million people in the population, only a sample of them are getting to take part in this other survey. This includes about 3% of the entire United States population. Sampling through the American Community Survey provides a lot of information about the United States population. According to it, we can find that the average household contains 2.65 people. We can also find that 20.9% of Americans speak a language other than English. We find that graduates holding bachelor's degree and higher, greater than 25 years of age. And let's see, that's going to be 50 million, or 5 million in engineering. You've got 8.7 million in education, and 2.9 million people in the visual of arts hold a bachelor's degree or higher. Now, that was just one way sampling can be used. Some other ways sampling could be used is, say, every fifth smartwatch on the assembly line is checked for defects. That doesn't mean they're checking all of them. They're checking every fifth to find out what the odds of one being broken is. The speed of every 10th car on a highway is recorded to find travel data, or maybe out of 15 classes, 3 are surveyed to record their preferences in pets. These are all examples of surveys that can be done to collect data, and that data is turned into statistics so that we can use that information to make other decisions. Let's get into some real definitions here. Statistics is a practice of collecting and analyzing data. It can be used to gain information on a population. And of course, a population, we'll highlight that. I'm going to highlight the population one separate. Population is defined as a group being studied. Now, that doesn't necessarily mean a group of people. It could be a group of dogs, a group of horses, a group of plants being studied. Even a group of, I don't know, little pieces of DNA or something, I guess. A sample is often used instead of the entire population, and a sample is part of the population and should represent the population. And there's the next definition right there. Whoops, didn't mean to do all that. Let me fix that. I'm going to clear it. And we'll only highlight what we want highlighted. There we go. A statistic refers to a single measure of some attribute of the sample. A statistic that is used is a percent of the sample that share the same attribute or response. And we're going to get into that a little bit more to help you understand it better. Data drawn from the sample is often collected in the form of a survey, which is a question or set of questions designed to gain information about the population as a whole. Lots of vocab words here. For each of the three survey topics, determine whether each phrase describes a population, meaning everybody, or just a sample of the population. 25 randomly selected 7th graders, that's going to be a sample of the population. Meanwhile, all the students in the school, that's going to be the entire population. Let's look at the next one. All the residents of a town, that's the population. The customers of a local ice cream shop, that's just going to be a sample of the population. And the last one, 350 residents outside of City Hall, well, that's still just going to be a sample because that's only the ones that showed up to City Hall. Meanwhile, all the residents of the city, that's going to be your entire population. Next, we need to talk about valid sampling methods. When choosing a sample from a population, it's important to use a valid sampling method. A valid sampling method is one that has all three of these. First, it is representative of the entire population. Second, it is selected at random where each member has an equal chance of being selected. And finally, it is large enough to select the accurate data. So the randomness is very important. You can't just take and select everybody in one group or everybody that drives a certain car. This even takes place in safety checks and law enforcement. When you're driving along the road and you see the police are stopping cars to look for driver's licenses and insurance and stuff like that, they have to follow very specific rules. They can't take and say, oh, that car looks like he's going to probably have a turd in it, so we're going to go for that one. Nope, they have to use either every car or every fifth car or something very random, specifically random though, so that they're not being biased towards any one population. Now, in this lesson, you're going to learn about three different types of valid sampling methods. They are stratified random sample, systematic random sample, and simple random sample. And we're going to define each of those below. The simple random sample is each item or person in the population has an equally likely chance of being chosen as anybody else. An example, 25 student names are written on a slip of paper, they're placed in a basket, and one name is randomly selected. That would be a simple random sample. The next type is going to be the stratified random sample. You all might want to pay attention to these because they're going to be on a vocab quiz and they're pretty similar. In this, the population is divided into groups with similar traits that do not overlap, while a simple random sample is then selected from that group. So say, for example, students at the school are divided into 6th, 7th, and 8th grade. A random sample from those 25 students from each grade is chosen. So you divided them into a group grade level, and then you took a random sample from each grade level. And finally, your systematic random sample, that is going to be selected from a population according to a specific item or time interval. Every 10th customer at the store is given a survey, or a customer is chosen to complete a survey every half hour. That's what we were talking about on the police roadblocks, where they have to say we're going to select every 5th car or something like that, and that's how they're going to be doing their stops on it. Let's take a closer look at those. The principal of a school of 60 honor students in 6th, 7th, and 8th grade wants to take a random sample of them in order to conduct a survey. On the next 3 slides, we're going to present with a valid sampling method to follow the instructions on the slide to view how each sampling method can be used to obtain a random sample. First, we're going to take a look at the random sample. For the random sample, they said choose students at random. And then we're going to shade the cells that take and represent the students that were picked. So we picked 14, we picked 19, we picked 45, we picked 17, 21, 7, 18 is right there, 30 is right here, 56 down here, and 5 is right there. And that would be an example of a random sample. Now we could take and reset that, and if we reset it and did a random sample again, you're going to see that we have different numbers this time, but it all varies on which one we're going to do, on how you want to do it. Next, we're going to look at a stratified random sample. For the stratified random sample, they broke them down into 6th, 7th, and 8th grade. And you can see that they are all grouped in here together in one big pot of honor students. So that's the beginning of the day. They're all interacting together. Now we're going to stratify them, where we're going to divide them up into their individual group categories of 6th, 7th, and 8th grades. And then after that, we're going to take a sample where we're going to grab 4 random students from each group in order to make our surveys. I gotta say, that was a pretty cool graphic that went with that one. And finally, we have our systematic random sample, where here we're looking at every 6 student beginning with student number 6. So we would have student number 6, then we'd have student number 12, number 18, 24, 30, 36, 42, 48, 54, and 60. And that would be an example of a systematic random sample, where you set at what your interval is going to be to determine who's going to get to take the survey. For example 1, the Astronomy Association wants to take a survey to decide the theme of the annual celebration. They are presented with 3 descriptions of ways that they can take the samples. For each sampling description, select a valid sampling method to represent it. So, our first option says for each yep, that's what we just said here. A computer randomly chooses 500 members from the list. That is going to be a simple random sample. Next, members are separated by state, and 10 people are randomly chosen from each state. That is going to be your stratified, I believe. Yep. And then finally, on the list of each member, every 200th member is surveyed. That's going to be your systematic random sample. Pretty easy stuff to do there. We're going to move on to the next one, which is going to be extra example number 1, which you're going to pause the video and work on your own right now. Identify valid samples. Go. For each sampling description, identify the valid sampling method that best describes it. So here, from a batch of 22,000 employees, every 150th is going to be tested. That is going to be your systematic sample. Next, the State Education Department wants to measure the effectiveness of new arts curriculum. So they divide the schools, you divide it right there, that's your key part, in the state into 3 groups: rural, urban, and suburban. Then performance of a random sample of each group is analyzed. That's going to be your stratified sample. And finally, to determine whether a candidate for governor is population, a computer-generated random sample of 1,000 voters are surveyed. That is going to be your simple random sample. Check it. Easy math. That's where we're going to stop part 1 of this video. Come back and let's check out part 2 in a little bit as we continue our study on biased and unbiased samples.